Today we are going to be looking at square roots and then estimating. So previously we have learned that squaring a number means we are multiplying by itself. The opposite of squaring is finding a square root. To find the square root, you must find two equal numbers whose product is that number. So it's going to be the reverse of squaring. So, for this example, the square root of 36. What times itself gives you 36? Oh, that's 6 times 6 gives us 36. So, the square root of 6, or square root of 36, gives us 6. The definition of a square root of a number is one of its equal factors. This symbol right here, we call that a radical. So it is used to indicate when you are finding the square root of the number that is underneath it. When you take a square root of a number, you will have two solutions. A positive solution and a negative one. So let's look at the square root of 16. What times itself gives you 16? 4 times itself, so 4 times 4 is 16. Also, what about negative 4 times negative 4? Negative 4 times negative 4 also gives you 16. So the square root of 16 is positive 4 and negative 4, which we could also write it as a plus or minus 4. So positive and negative 4. The symbol reads as plus or minus. So let's go through some examples. The square root of 49. What times itself gives you 49? That would be 7, but we have two solutions of plus or minus. So plus or minus 7. I want you to do the next 3, then come back and check your work. Okay, let's check it. Number 2, square root of 36 is plus or negative 6. 3, the square root of 4 is plus or minus 2. And lastly, number 4, the square root of 25 is plus or minus 5. So we have two solutions when we deal with square roots. But if we're dealing with a principal root, we just want the positive solution. So the square root of 81, we would say, is equal to 9. 9's the principal root. So on the back, with estimating, we're just going to deal with the principal. So let's look at this. A perfect square is a number made by squaring a whole number. So square root of 25 is 5 because we can take 5 and square it. 5 itself is a whole number. So numbers like 25 and 81 are perfect squares because their roots are whole numbers. but there are other numbers that are not perfect squares. So if we type in the square root of 2 in our calculator, we would get something like this: 1.41421356 The number keeps going on. And let's try it with the square root of 15. We would get 3.8729833346, and again, it's continuing on. So these square roots here, these values are not whole numbers. So let's look into that. These numbers itself are not integers or rational numbers because we cannot write them as a fraction. They also, the decimals, do not terminate, so they do not stop. And they're not repeating. So again, we can't turn them into a fraction. So these are irrational numbers. So when we have the square roots being irrational numbers, we want to estimate. So to do that, let's look at the steps. We're going to list out the perfect squares to find two perfect squares that are the closest that we can get to 22. So let's look at that. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So 22 is going to be somewhere between here. So our second step is between what numbers is in between? It's between 16 and 25. So we need to figure out which number it is closer to. If we have a number line to visually see this, and we have the square root of 16 and then the square root of 25. Square root of 16 is 4, and the square root of 25 is 5. So it's going to be in between 4 and 5. We need to figure out if it's closer to 4 or closer to 5. The number 22, is that closer to 16 or closer to 25? It's closer to 25. Since it's closer to 25, we are going to use 5 as our estimate. So since 22 is closer to 25 than it is to 16, the best whole number estimate we said was going to be 5. So let's look at a couple examples. We are going to estimate the square root of 45. So let's write out our square roots. The 1 squared, 2 squared is 4, 3 squared, 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So square root of 45 is going to be in between these two. So is 45 closer to 36 or 49? It's closer to 49, so the square root of 45 is going to be an estimate value of 7. The squiggly equal sign just means that it is approximate. So let's look at number 2. we have the square root of 130. So we already have this list going to 49. So let's just continue it on. So 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. So 130 is in between these two values. Now we need to see if 130 is closer to 121 or 144. It is closer to 121. So the square root of 130, its estimated value is going to be 11. So it's approximately 11. So when you're doing these problems, you can, at the top of your worksheet, you can always just write out this and refer to it for each problem instead of having to rewrite it every problem. So that's it for square roots and estimating square roots. So if you have any questions, please reach out.